Okay, good morning. Welcome to
KidMath number 67.
KidMath number 67. So for our movie yesterday, KidMath67, we had a line and a circle and a parabola.
No, it was a line and a parabola.
Right, it was a line and a parabola. Today I want to do line and a circle. So first, can you draw me the situations for how a line and a circle can intersect? You can just use one circle and you can draw different lines on your picture with it has a circle.
Let's just use this circle.
Okay, there's a circle.
So you have a tangent line.
Okay, it could be tangent, so we could have one intersection point.
Two intersection points.
Two intersection points.
Or just zero intersection points.
Zero intersection points. Okay, is it possible to have three intersection points?
No, because when we did a parabola and a line... no. It's not possible because you have a straight line and you can't like bounce back on itself like that.
Right. When you cross the circle, as opposed to when you're tangent, now you're inside the circle. And when you cross again, now you go outside the circle. So if you crossed one more time and had three intersection points,
It wouldn't be a circle.
well, it would be hard to do. You'd be back inside the circle somehow. Or even just touching it, but either way, you're already outside the circle. Okay, so what I want to do is I want to find, and I should have probably even tested this ahead of time, but I did not. Let's find out where the line y equals x plus 1 and the circle x squared plus y squared equals 9 intersect. Okay, so first of all, what is the circle x squared plus y squared equals 9? Can you tell me about that circle?
Well, the radius is 3.
Okay.
And
Where's the center?
it's 0, 0.
Okay. So here we have a circle. Let's just say that's radius 3. What about the line y equals x plus 1? What is that going to look like?
Well, it's going to be we have our y equals x line,
Okay.
but y equals x plus 1 will just be 1 more.
Okay.
It'll be shifted up 1.
Okay, so draw it in y equals x plus 1.
So maybe something like that.
Okay, well it doesn't cross through the origin.
Yeah.
When x equals 0, well I know you didn't quite draw it that way, but let's draw it emphasizing the fact that it doesn't go through 0, 0.
Okay.
Okay? There you go. Okay.
Something like
And
that.
what is this point here? That's when x equals 0.
When x equals 0, y is 1.
Okay, and what about this point here when y equals 0?
When y equals 0, this is negative 1.
Okay, negative 1, 0. Okay, those are our points. Now what do you think we're going to do to solve this equation? Well, first of all, how many intersection points does it look like we have?
Looks like we have this one here and this one here, so
Okay.
2.
Alright, great. So,
But where do they intersect?
yeah, what are we going to do to solve this equation? These equations over here.
We could see what a few points on this line are.
We could. That's going to be sort of just guessing around. I want to use algebra to solve it.
Well, we know this distance here. This is 3.
Yeah. Let's go from the algebra. So look over at the equations.
Y equals x plus 1. And x squared plus y squared equals 9.
Yeah.
So, how can we use those equations to solve for these two intersection points?
Right, very good. Good question. How can we do that? What's the problem you're having?
Well, these equations don't have anything in common,
That's true.
aside from integers.
Mm-hmm.
Maybe we could square this entire equation.
If we squared this entire equation here, we would have y squared equals something. So y squared equals what? Square this side.
It's x plus 1 squared. It's x squared plus 2x plus 1, which is that's a quadratic.
Yeah, it is. Okay, does that give you a hint on what a good next step might be?
Well, we could substitute.
Yeah, let's
X plus-
substitute this in for that. So now our circle equation becomes x squared plus 2x plus 1 equals 9. Or 2x squared plus 2x, now what's 1 minus 9?
It's negative 8.
Minus 8 equals 0. Now we have a quadratic equation, and we can solve for the roots.
Alright.
How are we going to do that?
Well, first we have to divide by 2.
Well, we don't have to, but we can.
Well, yeah. But it's easy because
X squared plus x
all the constants are even.
minus 4 equals 0. Okay, so that's going to have the same roots. What do you want to do now?
Well, this is going to be an x squared plus 1/2 x.
Oh, you're going to use completing the square.
Yeah, we're just
Okay.
completing the square.
All right.
So x squared plus 1/2 x.
Okay, so what do I have to add to the equation? X squared plus x plus, if I'm going to do completing the square?
1/4.
1/4 minus 4
Minus 1/4
minus 1/4
equals 0.
equals 0. Okay. Now, I'll use one more line down here. So this is x plus 1/2 squared equals 4 plus 1/4. So that's 16/4. 17/4.
Yeah.
Okay, and what now? Let's go over here. What are you going to do now?
Well, now we take the square root. We take the square root of both sides.
Okay, and what do we get?
We get x plus 1/2 equals plus or minus the square root of 17/4.
Which I'll write as the square root of 17 on the top
Over
and 2 on the bottom. Okay, and that is x equals negative 1/2 plus or minus the square root of 17 over 2. So I've learned the x values of my intersection. Okay, which one of these is positive and which one's negative? Which is the positive one, which one's the negative one?
Well, the one with the plus, negative 1/2 plus 17/2 is greater,
It's not 17/2.
square root of 17/2.
Yes. Okay.
That's the positive one.
All right.
And negative 1/2 minus the square root of 17/2 is this one here.
Okay, now I need to find the y coordinates too. Now, I'm going to tell you that finding the y coordinates is a snap. Okay? How do I know what the y coordinates are in just an absolute, just like 1 second? Boom.
Well, y minus 1 is the exact same thing.
Right, y equals x plus 1. So the y coordinates are going to be plus 1 to this, right? So 1/2 minus 1/2 plus 1 is 1/2 plus or minus the square root of 17 over 2. And if we had lots of extra time, we could check that these work.
We don't have too much time.
We don't have a lot of time. That's fine. This is what we do. We substitute, we eliminate a variable. Just so we have two equations with two unknowns. We eliminate a variable, eliminated the y squared, solved it. We could have used the quadratic formula here too if we wanted, but instead we used completing the square to get the solutions. And then boom. We're done.
Alright.
Good job, sweetie pie. Good job. Sorry that ran a little long.